All right, so I am going to go over quiz 4 of Math 2, Unit 2. So my last Math 2 video, I actually lied. I called it Unit 1. It's actually Unit 2 that we are looking at, which is all about proofs. So for quiz 4, there are some more definitions, even more definitions that we need to go over. The first one is actually definition. Okay, we all know what a definition is, or at least I hope we do. The description of an item or an object. Usually with math, it's going to be an item like a triangle. The definition of a triangle, or the description of a triangle would be the definition of a triangle, or it might be the definition of what a line segment is, anything like that. So it's going to describe an object, or it could describe a process. Okay, so definitions are used in proving all sorts of things in math. They're very important to understand and know the definitions involved, like any object that's involved in what you are trying to prove. It's a good place to start your proof out with our definitions. Okay, postulates, I should say definitions are descriptions, so we don't have to prove that they're true. They're just kind of given. They're a description of something and not anything that needs to be logically really kind of thought through, right? So postulate is kind of similar. It's something that it's not something that needs to be proved. It's something that's generally accepted as true. So it's any sort of concept or idea that is accepted to be true. Okay, it doesn't need to be proven. You just kind of say, oh yeah, yep, we're going to accept that this idea is true. Okay, axioms are just another word for postulate. Okay, so axioms are postulates. And none of these three need to be proven to be true. So definition, axiom, postulate, all of those are just kind of given to you. You don't need to put forth any more effort to prove that they are true. You just accept them and you use them in your proofs because they are accepted by everyone to be true. Okay, that kind of leads us to corollaries. Corollaries, or a corollary, needs to be proven to be true, but it tends to be a very short proof because we'll use theorems. Okay, so short proofs and they're usually quite short, and that you will use, they're easily proved by a theorem. So you'll use theorems to easily prove that these are true. Proved true using theorems. Okay, so they're like a quick and easy thing to prove that it's true, or a corollary is short and easy. Okay, a theorem takes a little bit more effort, so it's something that, if you remember the last video, we talked about like using your reasoning skills to come up with a conjecture. So you use inductive reasoning, you look at patterns in life or patterns in math that you find to be happening all over and over, and you create a conjecture. You create an if A, then B statement. Okay, theorems take our conjectures and they prove them to be true. So you begin with the conjecture and you go through definitions, postulates, axioms, corollaries, whatever you need, and you prove that that conditional statement is true, and then it becomes a theorem. So to shorten that, we're going to say it's a conclusion. Conclusion. I hope conclusion has two S's. I have a feeling it doesn't. No, I think it has one S. Sorry, guys. Good thing I don't teach language arts, right? Okay, so a conclusion proved by deductive reasoning. Okay, so deductive reasoning takes, again, deductive reasoning is taking your rules and ideas and using them to prove something's true. So a definition is a rule of something. Postulates are ideas. So we're going to take these rules and these ideas and we're going to prove that our conditional statement is true, and that gives us a conclusion about it, something that we can use in the future to prove more things are true or to solve problems, which theorems are what we use all the time in math to solve different problems. So there are some definitions that we need to know. I'm going to go ahead and create a new board for us, and we can talk about where they are useful or what types of proofs that you will need to know for this quiz. Okay, so I realized that here we are talking about corollaries, theorems, and all of this for proofs, and we haven't even defined what a proof is. So a proof is a logical arrangement of definitions, postulates, and previous theorems that have already been proven, so that you can come to the conclusion that your statement, which in our case is most often, at least in this unit, will be a conditional statement, that it is true. Okay, so you're going to use your ideas or your rules, which are your definitions, and your ideas and other rules like postulates and theorems to come to a true statement or to determine that your statement is true. Okay, so there are different types of proofs. The first type that I want to describe to you is a two-column proof. Okay, so we have two-column. So two-column proofs, as it says, it has two columns. Okay, on the left-hand side, you are going to put your deduction. So this is where we use our deductive reasoning. And we will go through and we will list them, right? You don't have to number them necessarily, but they'll be kind of in a list going down using your deductive reasonings, and it leads you to your conclusion. So this is a lot like our syllogism. If A, then B, and if B, then C, kind of leads us to say, well, then if A, then C. So you kind of guide your way through all of these statements. You can use definitions, postulates or axioms, other theorems, and they kind of lead you down. It's like a domino effect. It kind of gets all the way down and takes you to the conclusion, which will then prove your statement, your conditional statement, that it's true. So this is the left-hand side. You give all of your deductions over here. And then on this side, you're going to give your reasons. So this is just describing why you can say or what your deductions mean. Why can you do that? Well, here's why. Because blah, blah, blah. And it just gives an explanation. That's reasons or explanations as to why those work. So this is a two-column proof. Left-hand side are your deductive or deductions. Right-hand side are your reasons. Okay, there are other proofs. Let me clear the board and I'll explain those other types. All right, so the next type of proof I want to talk about is called a flow chart. So flow charts use bubbles. And I'm sorry, I keep trying to make sure you can read the board, and I think I keep making it worse somehow. I don't know if that's any better. Maybe. Okay, so anywho, flowcharts. Flowcharts use bubbles and arrows to kind of guide you through the process. It's more like a map to get to the end result or the proof. So you're going to start with some sort of statement. We've actually used these in note-taking before, we weren't proving anything, but it kind of helped us guide things along. So we have an original statement, and then that will guide us to something else, and that guides us more, and then we just keep going and keep going, and ta-da, that's the end, then we get to stop. Okay, they actually don't use exclamation points to show the end. They say at the end of a proof, oftentimes you'll see QED. Okay, it's probably Latin or something. I can't tell you exactly what that means. I once upon a time knew, but I don't now. Or you might see a box, a little square placed at the very end, and that just kind of says, okay, we're done, we've proved it, voila. All right, so the last type of proof I'd like to talk about is the indirect proof. It's also known as proof by contradiction. So in college, my professors always called it proof by contradiction, same with the textbooks, but in Apex, I noticed that they tend to lean more towards indirect proof. But they also use proof by contradiction, so you're going to see both of those show up in your quizzes. However, they mean the same thing. So a proof by contradiction or an indirect proof is where you take your original statement, your if A then B statement, conditional statement. You're going to take that and you're going to assume the very opposite of that. Okay, so you need to make an assumption that is opposite Okay, first step. So your first step is to make an assumption that is opposite of what you are trying to prove. And then you go through, and it's often like the like a two-column proof. It could be a two-column proof or a flow chart. I haven't used very many flow charts for proofs, but what do you know? You can. Okay, so a two-column proof or just a paragraph proof. Those exist as well. You can just write paragraphs out, and you go through and you describe everything that's happening. You're going to use your definitions, postulates, and theorems to try and prove the opposite of what you want. So you go through, and this is us. We're proving stuff. Dot, 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 dot. Here we are, proving, proving, proving. And you reach the end of it, and you're like, uh-oh. You now get to something that is a contradiction. So assume the opposite. You go through proving, and this leads to a contradiction. Okay, which is why the word or the term, my goodness, hopefully that's better. Okay, it looks fuzzy down here now. Gosh, guys. Okay, this is why it leads to, or it's called often a proof by contradiction, because it leads you to a contradiction, something that cannot be true. So you assume the opposite, you go through and you prove it as if that's what you really wanted to prove, and then you get to this contradiction where you're like, hey, hold up, that can't be true, and therefore that tells you that the correct one or the original statement is true, since the opposite cannot be true. Think of it as like your converse, when you swap the order of things, how that's never true. It's kind of like that. So you get through, you assume the opposite, you get through and you're like, oh, wait a minute, that one can't be true. Therefore, my original statement is now true. And you will end that either in QED or a little square, and that signals the end of your proof. Okay, now there's one more thing that I forgot to mention as far as words and things that you will need to know, and that is common notions. I don't really think of these very often, probably maybe because they're common, but Apex definitely wants you to know about them. So common notions are just things that are accepted to be true with very little thought. It's kind of like common sense. If I hold a glass of water over my head and I tip it, the water's going to fall out on my head. That's a common notion, right? Gravity is going to pull that down. We just kind of accept that to be true. We don't need to prove it. So common notions, definitions, postulates, or axioms, none of those need to be proven to be true, but they can be used in a proof. And that's really all of quiz 4. So good luck.